Okay, this is a 2010 Form B problem 1, so you can look that up. And we're going to be describing some box plots, and we're also going to be creating a stem and leaf plot. So as a part of the United States Department of Agriculture super dump cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the target river sites were River X, Y, and Z, had become contaminated with pesticides because they were located near abandoned pesticide dumps. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump site. So we basically have 3 rivers, and we've taken multiple sites on those rivers looking for the amount of aldrin in the river, which was a pesticide. The box plots shown below display the 5 number summaries for the concentrations in parts per million. Like, well, gosh, the box plot always shows that for the 20 locations of that 3 rivers. So the very first thing it asked us to do was to compare the distributions of the concentrations, all right? So it asked us to compare the distributions of the concentrations. So as I look at that, the very first thing I notice is, wow, River X is much more spread out and it has a higher median. So as I go to address that, River X is skewed to the right. It's like, yeah, it's somewhat stretched, or oops, it's somewhat stretched to the right for sure, all right? And has the highest range, interquartile range in variability. River X has the highest median, with 50% of the readings being greater than 5. And remember, the median is 50%, so 50% are greater than 5, and that is higher than any of the others. River Y, on the other hand, is reasonably symmetric. And once again, the distance from the minimum to the median is about equal. So reasonably symmetric. It's not perfect, but reasonably. And it has a median of 5, and its range is the second largest. Once again, I've made the comparison that it is, the range of this one is second in size to River X. On the other hand, I could have talked about the IQR being second in size. I just need to make sure that I talk about one of the measures of variability. Then River Z. River Z appears to be skewed to the left and has the smallest range, IQR, and variance. It has a median of about 4.3, and I'm estimating that. All of its readings are below the upper 50% of River X. And here's how I come up with this. That's the median, and all of this one's readings are below River X. So River X not only has the highest median, probably has the highest pollution, but it also has the highest variability. River Z has the lowest variability and probably the least amount of pollution. Okay, so that's part B. Part A. Part A, really important. And I'm going to leave that on the screen for just a moment so you can pause it and copy all of that. Okay, part B, while it's there, it says, the 20 concentrations of aldrin for River X are given below. So this is just for River X. Construct a stem plot that displays the concentrations of aldrin for River X. So I'm going to take a look at my calculator, and I'm going to go to Stat Edit. I'm going to go up to the top and clear and press Enter. Clear that again and press Enter, and clear that again and press Enter. So I've cleared out all the data, and I'm going to input these data beginning at 3.4, and I'm going to pause this recording for a moment while I do that so you don't have to wait on me. Okay, so now that we have all the data entered in the calculator, we have that entire table entered into column L1. The hard part about making a stem plot is getting them in order from least to greatest. So we're going to go and let the calculator do the work for us. And we're going to just press second, followed by the stat button or the list, and arrow over to the word ops, sort ascending. And I want to sort L1. Tells me it's done. So I should be able to go back to stat edit. And sure enough, we have 3.4, 3.7. So when I'm doing this, remember the number furthest to the right makes up my leaf. So this is going to be 3.4 and 3.7. Then I have a 4. So that's going to be a 4.0, a 4.2, a 4.3, a 4.6, etc. And I scroll down and I notice that there's nothing in the 6s. We went straight from 5.6 to 7.3. Okay. Please make sure you always have some sort of key. So here we have 7.3 parts per million of alderite. All right. So there's my key. There it is. I made it up. This is my stem. These are my leaf. And in this case, the decimal point basically lies on that line. And never ever skip a number on the stem. Never ever skip a number on a stem. Even though there are no 6s, we have to put the 6 there because this is essentially a number line. We also don't put 6.0 because we didn't have a 6.0. We did have an 8.0 and we also had a 4.0, but we didn't have a 6.0. So we just leave it blank. Okay. All right. Part C. Describe a characteristic of the distribution of aldrin concentrations in river X that can be seen in the stem plot, but cannot be seen in the box plot. So we're looking for something that we can see in the stem plot over here that we can't see in the box plot. So let's take a look at both of them. But when I look at this, what I can see here is I can see a gap, and I cannot see the gap in the box plot. So that's what I would say. The gap at 6 cannot be seen in the box plot, but is visible in the stem plot. The stem plot appears to show 2 clusters, one centered at location 4 and one centered between locations 7 and 8. All right, so that's the way you would write that up. Hopefully that will help with that. Thank you.